Did you know that a single rotation of Venus takes longer than an entire year? It's true. In our solar system, Venus holds the record for the longest rotation period of any planet, 243 Earth days, while it completes its orbit around the Sun in just 225 days. Isn't that mind boggling? But how is this even possible? Today, we're diving into the fascinating world of Venus and uncovering the reasons why a day on this mysterious planet exceeds the length of a year. Venus, the second planet from the Sun, closely resembles Earth in structure but has some unmistakable quirks. With a diameter of approximately 12,000 kilometers, it spins on its axis in the opposite direction to most planets, including our own. But beyond its peculiar rotation, there's something even more astounding. Its sluggish spin results in days that are extraordinarily long compared to its rapid orbit around the Sun. To start, let's break down Venus's unique rotational characteristics. It takes 243 Earth days to make one complete rotation on its axis, while it only requires 225 Earth days for its orbit around the Sun. This unconventional pattern means that one day on Venus is slightly longer than 1 year. On Venus, you won't experience the sun rising and setting daily as we do on Earth. Instead, the sun rises only once every 117 Earth days. Yes, that's right. On Venus, the sun rises twice a year. Moreover, due to Venus rotating in the opposite direction, you'll see the sun rise in the west and set in the east. Interestingly, despite its similarities with Earth, Venus has attracted less scientific interest compared to other celestial bodies, such as Mars. So, why is that? A recent study led by astrophysicist Stephen Kane from the University of California suggests that Venus's thick, turbulent atmosphere might be the culprit. Kane theorizes that without the influence of this dense atmosphere, Venus would align its rotation with its orbit around the Sun, a phenomenon known as tidal locking. In scientific terms, a solar day refers to a single rotation of a planet around its axis, while an orbit defines the time needed to complete a full circle around the Sun. Despite being smaller than Earth, Venus's proximity to the Sun allows it to orbit more quickly, making it travel a shorter distance under the gravitational pull of the Sun. Another critical factor that contributes to this oddity is Venus's dense and volatile atmosphere, composed primarily of carbon dioxide and sulfuric acid, which generates a runaway greenhouse effect. This results in scorching surface temperatures that can reach a staggering 900 degrees Fahrenheit. To ascertain why Venus has retained its slow rotation, Kane analyzed how long it would generally take for a planet like Venus to become tidally locked, factoring in various characteristics such as mass and gravity. His computation revealed that Venus should have become tidally locked in just 6.5 million years, a mere blip in the 4.5 billion year history of our solar system. This leaves us with the question, what prevents this lock from happening? Kane posits that the planet's thick atmosphere plays a significant role in this process. Interestingly, the sun acts as a braking force, allowing the atmosphere to avoid tidal locking. Understanding the relationship between atmospheric conditions and tidal locking could yield significant insights, especially for exoplanet hunters who use telescopes like James Webb to seek out potentially habitable worlds. Kane advises researchers to investigate whether some of these far off planets could be experiencing a similar phenomenon as Venus. In summary, the contradiction of a lengthy day on Venus compared to its shorter year is a result of its bizarre rotation, thick atmosphere, and proximity to the Sun. This distinctive relationship provides invaluable